Hello everybody. So this video will deal with a full system of numbers, the decimal, binary, octal, and hexadecimal. So we're going to learn how to convert from one unit to another unit. So let's go to it. Let's start right away. How Hello everybody. So this week we're going to talk about full system of numbers conversion. We're gonna deal with binary, octal, hexadecimal, and decimal system. We're gonna learn how to convert from one number system to another one. So let's get started to it. So first, we're gonna convert from octal number to binary number using the decimal. So as you can see here, I have number 73. So I'm going to change that to decimal first. So I'm going to write down 7, make a little bit bigger, 73. This one is octal number. So I put down the base is 8. So I write out 7 multiply 8 to the 1 plus 3 multiply by 8 to the 0. So 7 times 8 equal 56. And 8 to the power of 0 equal 1. So 3 times 1 equal 3. So I end up having 59 at the decimal number. Okay, so from this decimal number, I want to convert to the binary. So 59 equal 32 plus 16 plus 8 plus 2 and plus 1. With a plus on. So 32 plus 16 equal 48. 48 plus 8 equal 56. And 56 plus 3 equal 59. So I'm going to write out 1 for 32, 1 for 16, 1 for 8, 0 for 4, 1 for 2, and 1 for 1. So this is a binary number for number 73 octal. Okay, so make sure that you convert from octal to decimal first by having the base of 8, and then you convert back from decimal to binary. Let's do another problem. Let's do number 73, octal 73, to binary. But this time we're gonna use the substitution method by looking at the table. I'm gonna zoom it in so you can see that I'm gonna write out 73 octal, so base equal 8. Now I look at the 3 digits in binary represent for 7 and represent for 3. So I'm going to write down 7 equal 1, 1, 1. And 3 is 0, 1, 1. And I bring it close together, so I put out 1, 1, 1, 0, 1, 1. So this is binary. As you can see that this method is easier than change to the decimal number. You just look straight to the table and write down the binary equivalents to the octal. Make sure that you group 3 digits because octal number has combination from 3 digits, from 0 to 7. So that's the way you convert from octal to binary. Now let's look at another example. What would happen if you want to convert binary to octal using the substitution method? So I look at the example on page 111. As you can see that 1011. So I'm going to write out 1011, 1011. This is a binary. Now, in order to convert to the octal, you form groups of 3 bits starting from the right. Add 0 to the left is needed, and convert each 3 bit group to an octal using the table that you hear. So I'm going to group 3 digits together, 0, 1, 1 from the right to the left. And if I don't have another digits, then I add 0. So you have so now you got a group of 3 digits formed together, make it octal. So now you say that 001 is 1 and 011 is 3, so you got 13 as an octal number. So this is very straightforward. You convert from binary to octal, make sure that you form 3 digits. Go from right to your left. If you don't have enough digits, then add 0, and then you convert back to the octal. All right, so look at another example. And this example, we want to convert hexa number to binary using the substitution. Hexadecimal number starting from 0 all the way to letter F, 0 to 9, and after 9 you got A, B, C, D, E, F. So let's do number 32. So now because hexadecimal, you have to have a 4 digits representing the 16 digits in hexadecimal system. So I'm going to write out 32. This is a hexadecimal, so I write out the base equals 16. And I break it to 3 and 2, but make sure form 4 digits. So 2, you got 0, 0, 1, 0. Oops. This one doesn't work, so 0, 1, 0, 0, 1, 0. And the other one is 3 is 0, 0, 1, 1. So now you put it together, so you got 0, 0, 1, 1, 0, 0, 1, 0. So that is the hexo 32 convert to the binary number. So again, when you have a hexa number, you make sure that you group 4 digits for each single hexadecimal, and then you combine them together, put it together, and then you will have a binary equivalent to that hexa. Okay. Now, let's look at another example. Let's say I have AB. This is a hexadecimal, so I put out base equals 16. As you can see that A is 10, which is A and 2, so 1 for A, 0 for 4, 2 for the A and 2 make it 10, all right? And B, you look at B right here, so equal 1011, 1011. So you look at A and B, this is A, and this is B. So A and B equal 1010 and B equal 1011, and you put it together. So 1010 1011. So that is the binary equivalent to AB hexadecimal. All right. Convert binary to hexadecimal using substitution. So now you are given the binary number 1110, and you want to convert to hexadecimal. So make sure that you group 4 digits working from the right to your left. And in this case, it already have a 4 digits. So you know, look at 110. So this 1110, so this is letter E right here. 1110. So letter E. So this 110 equal to letter E for hexadecimal. Okay. Page 117, how to convert from decimal number to an octal using the binary. So you are given 34 at the decimal number, so I write out 34. That is the base of 10 decimal number. And you want to convert to octal. So you know octal have 3 bits for its single number. So 34, 4 is using the binary. So okay, now we want to convert decimal number to an octal number using binary. So first you have to convert 34 to 34. You want to convert that to the binary. So 34 equal 32 plus 2. So you got 32 plus 2 equal 34. So 1 for 32, 0 for 16, 0 for 8, 0 for 4, and 1 for 2, and 0 for 1. So that is the binary number for decimal 34. So now, in order to change to octal, you have to group 3 bits from the right to your left. So 3 bits. Okay, so now the octal for 010, all right, so you're gonna write down is 2, 10 is 2, and 100, that means 4. So you got 42 octal number for decimal 34, okay? Moving on to page 121, how to convert octal number to decimal. Octal number to decimal using binary. So you got octal 70, bring it back. Bring it back. Okay. Now you want to convert octal numbers to decimal using binary. So you are given number 72 as an octal. So I write out 72, then octal number. And you want to convert to decimal by way of using the binary. So what is 3 digits represent number 7 and 3 digits represent 2. So you got 0, 1, 0 for 2, and 7, 7 is 1, 1, 1. 4 plus 2 plus 1 equals 7. So now we want to convert back to the decimal number. So you got 6 digits here, so start with 32 with 1 plus 16 plus 8 plus 0 plus 2 and plus 0. So 32 plus 16 equal 48. 48 and 8 equal 56. 56 and 2 equal 58. So the decimal is 58. Okay, write our little 10 here, indicate the subscript for decimal number 58. So make sure that in octal number, you have to group 3 bits together. All right, next is move on to page 125. And you want to convert the decimal to hexa using the binary. So decimal number is 20, and you want to change to hexa. But before you change to hexa, you change to binary first. So I'm going to write out 20. Change to binary, you got 16 and plus 4 equal 20. So what's the binary of 20? 1 for 16, 0 for 8, 1 for 4, 0 for 2, 0 for 1. So that's a binary. Now you want to change to hexadecimal. Make sure group 4 digits, 4 bits all the way from right to left. So you got 4 bits right here. And now I'm going to write out 0, 0, 1, 0. So next one, another 4 bits. So you got 1, and you don't have any more bits, so you add 0 and make it 8 bits word here. So now you want to change to decimal. So you know we're going to start with 32 plus 16 doesn't have it, so plus 0 and plus 8 and plus 0 and 0. So 32 plus 8 equal 20. 32 plus 8 equal 40. So your answer is 40. So okay. Erase this. Okay, now you want to convert the decimal number to hexa using the binary number. So you're given number 20 as a decimal number and you want change to hexa. But before you change to hexa, you have to convert to the binary. So I'm going to write out 20. I'm going to write out 20 equals 16 plus 4. So I want to change that to binary. So you got 1 for 16, 0 for 8, 1 for 4, 0 for 2, 0 for 1. So 10100 is a binary for number 20. So I put binary number here. And then in order to change to hexa, you have to form groups of 4 bits starting from the right and add 0 to the left if needed. Then convert each 4-bit group to its hexamal equivalent. So I'm going to form 4 bits group here. So I got 0, 0, 1, 0. That's for one group. And the other one is 1. You don't have another bit, so you add 0 to it. All right, now you have to change that to the hexadecimal. So this is 1, and this is 4. This is 4, so the answer is 14 hexa. Okay. Now you look at letter F. So the F is change to decimal, but go by binary, change to binary first. So F equal, look at that, F equal 15. So 15 equal 8 plus 4 equal 12. 12 plus 2 equal 14. And 14 plus 1 equal 15. So you got 1, 1, 1, 1, 1. And you form 4 bits group from the right to your left. So you just one group. The other one doesn't have enough 4 digits, so you add 0. And this hexa equivalent to this one is 1. And this one is 8 plus 4 equal 12. 12 plus 2 equal 14. 14 plus 1 equal 15. So you got oh, 1, 2, 3, 4. Let's do this again. Let's do another example. Let's convert hexadecimal F16 to decimal number. So as you can see, letter F is decimal is 15. All right, so F, you change to binary first. So letter F is 115, that means 1, 1, 1, 1, 1, 1, 1. So it has a 4 bits already. So 1, 1, 1, 1 is equivalent to, this is 16, equivalent to 15. So 8 plus 4 equal 12. 12 plus 2 is 14, 15. Decimal. And you can look at letter F is equal 15 decimal right there. Okay. Now, let's do another conversion from octal to hexadecimal using binary. So you got an octal is 42. So I'm going to write out 42. Octal number is 42. Let's do two more problems. On page 131, you want to convert from octal to hexadecimal using binary. So I'm going to write out 42 as the octal number, and I want to change to hexadecimal, but I'm using binary. So what is of 3 bits for the 4 and 3 bits for the 2? So 3 bits for the 2 is 0, 1, 0, and 4 bit for the 4 is 1, 0, 0. All right, now in order to change to hexadecimal, you need to have 4 bits, group 4 bits together. If you don't have enough bits, and then you add 0 to your left. And you go start from the right, go to your left. So you got 0, 1, 0, but you need 4 bits, so you add a 0 over here. And now you got 0, 1, and you don't have another 0, so you add another 0. So now you have 2 groups. Each group has 4 bits. So each group had 4 bits. So this is, you got 2, and I'm sorry, erase it. All right, so now you change to hexa, so this one, so you got 2, and this one you got also 2. So there's a hexa for 42 octal. So make sure that before you change from octal change to binary, you have to have a 3 bits word, and number 42 is 0, 1, 0 for 2 and 1, 0, 0 for 4. And after that, you want to change to hexa. You need to group 4 bits starting from the right to your left. And if you don't have enough bits, then add 0 to your left. And in this case, you got 0, 0, 1, 0 that represent 2. And 0, 0, 1, 0 represent another 2. So you got 22 hexadecimal. Okay? Let's do another one. So what would happen if you convert from hexadecimal to an octal? So you got the other way around. So you got 31 hexa, right? You want change to an octal, but using binary. So you know that hexa, you got to have a 4 bits group. So 1 is 0, 0, 0, 1, and 3 is 2 and 1, and make it 3. So you add 2 more 0. All right, so that is 31 for hexadecimal. Now you want to change to octal. You from 3 digits group from the right to your left. So you got 1, 0, 0 for one group of 3, and 0, 1, 1 for another group of 3, and then you got 0, 0, 0. Okay, so now you put down, or you don't need this 0. So you have 2 groups. each one have 4 digits. So this is 1, and this is, oh no, wait, cut. After you convert 31 to binary number using 4 bits, now if you want to change to octal, you group 3 bits from the right to your left. So let's write out 0, 0, 1, 1, 0, 0, 0, 1. Now you group 3 bits together, so you got 1 group, 2 group, and 3 groups. You add another 0. So this is 1, and this is 1 and 1, 0. That means 4 plus 2 equals 6, and this is 0. So the answer is 61 61 octal. Okay, write out 61 octal. 61 octal, that's your answer. So again, in order to change from hexadecimal to octal using binary, first you have to change 31. In this case, you make sure that you have to have 4 bits in each group. So 1 is 0, 0, 1, and 3 is 0, 0, 1, 1. Now from binary, you want to change to change to octal. You group 3 bits per each group, starting from the right to your left. So in this case, you got 1 and you got 6. The other one is 0, it doesn't count. So you got 61 octal number. Okay, so that's all you need to learn how to So make sure that you complete the assignment for this lesson 10 and 11. I got 18 questions, and I will post that on your Canvas, and make sure that do that in any kind of format, but make sure that when you save, you scan to PDF, so it's easy for me to load and grade it. So if you have a question at all, as always, make sure that you email me and let me know. I hope you have a good, productive week. And if you have any question, please. So that's all for this week. You need to convert 4 number system here, and make sure that you finish all the assignment or the example on page 108 to 134. There are 18 questions altogether. After you're done, submit it as a PDF, so it's easy for me to grade them, and try to finish by next Tuesday. And I hope you have a good, productive week. Have a good week.